Now that we've come up with our recursive formula, our next goal is to solve some problems using Newton's method. Our first problem has f of x equals x squared plus x, and we want to use the formula that we created to find the zeros of this function. It gives us a starting value of x equals negative 0.6, and we want to continue our iterations until we have two iterations in a row that differ by less than 0.0001. This is what your calculator does when it estimates the zeros of a function for you. It has a set tolerance, and it continues to iterate until it finds two iterations that are less than that tolerance. Also, it normally asks you to guess when you are trying to find a zero, and you are essentially giving it its starting value. We know that with Newton's method, we need both the function and the derivative of the function. So the first thing we should do is find f prime of x. The derivative of e to the x is e to the x, and the derivative of x is equal to 1. Next, we know that x1, our first iterative value, which is given to us, is equal to negative 0.6. If we want to find our next iteration, we need to plug into our model that we created in part 8. That tells us to take the previous guess, which was negative 0.6, and then we need to subtract from that f of 0.6 divided by f prime of 0.6. Plugging into our functions that we've got, this gives us negative 0.6 minus negative 0.0512 divided by 1.5488. Now, I recommend that you don't actually round these like I've done on the screen. That'll end up giving you some rounding error, and we might not get the correct answers that we're looking for. But I'm writing it down with this shorted method because I can't write out all the decimal values. Use your calculators to find these numbers, and then when you do, just keep them in there to find the solution for this. But for our second iteration, we end up getting a solution of negative 0.566950. Now I'm going to so many decimal places because remember we're trying to see if we are within 0.0001 of our previous iteration. Now the second iteration is not within 0.0001 of the first, but it's actually really close, all things considered. So when we go to do the third iteration, we might be even closer. We should be at least. So when I find x3, we take the previous iterated value of negative 0.566950, and we subtract from that f of 0.566950, and then we divide that by f prime of 0.566950. Now you can see this is getting a little bit tedious to write, so I'm not going to do this each time. But we do end up getting a solution that is a little bit closer to our true answer, and it is negative 0.567143. Still not within 0.0001 of our previous solution, so we're going to have to go again here and find x4. And I'll trust that you can plug into this process, and we end up getting a solution here of negative 0.567143. And this number is the same as this number here, so we are definitely within 0.0001 of each other. Now, if the calculator was doing this, it would see that these are really close to each other, and it would say, hey, we're done. This is as far as we have to go. So the solution to this is going to be negative 0.567143, at least an estimate for our zero. This process can get a little bit tedious to do by hand, as you can see from the work that's here on the page. So feel free to use your calculators to do the iterative process. Now, I don't have a calculator available to me on this computer to be able to show you, but I can give you an idea of what you'd need to do for this. You would first want to go to your y equals menu, and in y1, type in our iterative equation. So again, when we write this, it's always to take our x value, so we would take x, and then we would subtract from that our function f of x, so we would have e to the x plus x in the numerator, divided by our derivative, e to the x plus 1. That's not exactly how you type it in, but that's what you would need to plug into your y1. From there, you can go to table set, which I believe is TBLST, and tell it that for the independent variable, you want to be able to ask. And what this means is that you can go through and you can plug in your own values of x, and it will output a value of y, which corresponds to the y value from our iterative equation. So then you can go to the table, and you can start plugging in values of x. And the first value of x that you would plug in would be this negative 0.16. And what it should tell you then is that the output for that is this value of negative 0.566950. Well, then you can go through and plug in the negative 0.566950, and then its output value should be this third solution that we got. So essentially, you keep taking the output that the table gives you and putting it in as the new input for the table, and it will continue to do this iterative process for you. Eventually, you'll see that two solutions in a row are very, very close to each other, and you can stop at that answer.